NIST has been conducting research on positive pressure ventilation, or PPV, for 6 years. The focus is to improve firefighter safety by increasing the understanding of this ventilation tactic. NIST, with support from USFA, DHS, and fire departments across the country, is taking engineering principles and applying them to fire service tactics to increase the knowledge of the street-level firefighter. This DVD set includes experimental results, video, and reports to improve the understanding of PPV. In this presentation, I will explain PPV, briefly examine the results from previous work, and focus on PPV tactics in high-rise buildings. Our main objective is to improve firefighter safety by enabling a better understanding of structural ventilation techniques, including positive pressure ventilation and natural venting. We do this by conducting experiments to answer the common questions from the fire service, such as what is the best location to position the fan and where do you make the exhaust opening. PPV is a technique that is used by the fire service to remove smoke, heat, and other contaminants from a structure in order to perform other tasks in a more tenable atmosphere. Air from the outside is blown into a structure to increase the pressure inside. Air flows from a higher pressure to a lower pressure. You control the flow within a building. Our research began in a 3-story fire training building to answer the question, what happens to conditions for firefighters or potential victims when you vent, either naturally or with PPV, correctly or incorrectly? This series consisted of 28 tests. Each test had a fuel load of 6 pallets with hay. The position of the fire and the ventilation location was varied. Each fuel vent configuration was run using natural ventilation and positive pressure ventilation. Temperature, gas velocity, and oxygen were measured throughout the building. This is a comparison video of a fire on the 2nd floor that is vented out of an adjacent room. The video is sped up 4 times real time. The views on the left are naturally vented, and the views on the right are PPV ventilated. The inside views show that the visibility returns much faster with the use of PPV, but the fire size increases more quickly. All of the data and video views were analyzed. Average maximum ceiling temperatures were 1100 degrees Fahrenheit for naturally ventilated fires and 1200 degrees Fahrenheit for PPV ventilated fires. To say that using PPV makes higher temperatures is not necessarily true. Maximum temperatures of surrounding rooms of the fire room were almost always within 200 degrees Fahrenheit of each other, independent of the type of ventilation. PPV did not create temperatures in adjacent rooms that would be considered extreme as compared to naturally ventilated fires. PPV ventilated fires redevelop more quickly. This was not surprising as the fan forces fresh air to the fire. PPV also restored visibility much faster. In most cases, PPV did not create a higher temperature between the fire and the vent. In order to examine the possible effects on firefighters operating in the structure, temperatures at 4 feet above the floor were analyzed. NFPA requires that turnout gear resist thermal degradation for 5 minutes at 500 degrees Fahrenheit. So 300 degrees C, or 572 degrees F, was used as a benchmark threshold for evaluating potential firefighter tenability. The threshold temperature was not exceeded in any of the scenarios, in any of the rooms except the fire room. Temperatures were always lower between the fan and the fire room. To determine the potential impact of ventilation on any possible victims in the structure, a tenability threshold of 200 degrees Fahrenheit was used at 2 feet, assuming a person lying on the floor. The temperatures concluded that turbulent mixing by the fan caused higher temperatures at low levels beyond the fire room. Rooms between the fan and the fire room were cooler. In most cases, the victims located near the fire room saw temperatures above the threshold prior to ventilation. The second set of experiments is a comparison of a room fire ventilated naturally with positive pressure. The results show how much larger the forced ventilation can make the fire, as well as to see the conditions that are leading to the fire room and outside the ventilation window. The figures show the floor plan and the inlet door of the corridor to the room and the ventilation window. 2 similar rooms were furnished and instrumented. The fire was started on the bottom of the bunk beds and was allowed to grow until it became ventilation limited. In the first experiment, the window was opened and natural ventilation was observed. In the second experiment, the window was vented, a fan was turned on at the entrance to the corridor to positively pressurize. Temperature, gas velocity, and heat release rate measurements were made. These pictures show a comparison of the two ventilation techniques after ventilation. The photos on the left show the fan forcing the flow back through the room and out of the window, and the photos on the right show the combustion products leaving the room, out of the window, and corridor. The data showed that the room temperatures were lower for the PPV test due to additional fresh air. The PPV fan caused a 60% increase in burning rate during this time of initial fire department attack, but much of it occurred outside the room. The PPV ventilated experiment forced the flames at least 6 feet out of the room as compared to the 3 feet by the naturally ventilated experiment. This could be an issue if there are exposure concerns. The PPV forced all of the combustion products out of the window, creating better conditions in the corridor. Results that impact firefighters point out the coordination of firefighting crews is essential to carry out positive pressure ventilation in the attack stages of a fire. In a burning structure, any change in ventilation may lead to a rapid change in fire. In order to increase firefighter safety once ventilation has taken place and the fan was activated, the fire crew should delay their attack for 60 seconds until the fire has had a chance to react to the oxygen it received from the ventilation of the opening and the flow from the PPV fan. Complete a 360 or assessment to make sure the fan is having the desired impact before committing crews to a rapidly changing environment. It's important to select a ventilation opening near the seat of the fire to allow the increased burning to be vented to the exterior. Conditions leading to the fire room are greatly improved. This increases both the speed and safety of the crews.